All right, guys, on to section 5 of chapter 8. This one is using the distributive property. So previously we used the distributive property to evaluate expressions. Now we're going to use the distributive property to factor polynomials and to also solve equations of the form ax squared plus bx equals 0. Now we're going to use the distributive property in this section in a unique way. It's kind of like reverse distributing. So let's check some of this out. So we'll talk about what factoring means, factor by grouping, and the zero product property. So here's how we use the distributive property to factor. We've used the distributive property to multiply a monomial by a polynomial. You just distribute it into the parentheses, so to speak. Now you can work backwards to express a polynomial as the product of a monomial factor and a polynomial factor. So for example, if I have 1.6w squared plus 6w, you can think of that as having a w distributed to both of these. So like 16 or 1.6w times w plus 6 times w. And you can undistribute a w, one factor of w from both terms. Okay, so the 1.6w squared, after you undistribute a w, would still have a w with it. So it would be w times 1.6w plus 6. So factoring is that process. Factoring a polynomial involves finding the completely factored form. So what that means is factoring is similar to undistributing. It's reverse distributing. But when something is completely factored, that means you've kind of reverse distributed everything you possibly could have from the problem. So let's use the distributive property to factor each polynomial. Now if you notice this, they both have a factor of y, and 27 and 18 both have a factor of 3. But that would not be completely factored because the 27 and 18 have a bigger number than just 3 in them. Okay, you have to find what's called the GCF, the greatest common factor, and we did that way back at the beginning of the year. So we'll review it kind of quickly here. So if you write 27 in its expanded form, it's just 3 times 3 times 3, and then y squared is y times y. The 18 is 2 times 3 times 3 times y. The greatest factor is what factors they both have in common. Well, they both have 2 factors of 3 and 1 factor of y in common. So the GCF is 3 times 3 times y, or 9y. So you can write each term as the product of the GCF and the remaining factors. Now, if you can do this step in your head, by all means go ahead and do it, and just know that the GCF of this one is 9. If you need to write it out for each term, that's completely fine. Take your time, just make sure you get it right. Okay? So we can use the distributive property to factor out the GCF. So I can write 27y squared as 9y times 3y, and the 18y as 9y times 2. And then you undistribute or factor out the 9y, and you'd have 9y times 3y plus 2. So that's our answer, 9y times 3y plus 2. Now you'll know your answer, you're kind of done with your answer if what's left in the parentheses has nothing more that you can factor out of it. Okay? So let's look at this one. This one has 3 terms, but same idea. You want to find out what factors all of them have in common. I can see from the -4, the -8, and the 2 that there's at least a factor of 2 in both of them, all 3 of them. You have an a squared, an a, and an a. So the most that any one of them has at the same time is just 1 factor of a. And same thing with the b. You have a b squared, and a b. So the most you can kind of undistribute from all of them is a factor of b. Okay, so the 4a squared b, the 9ab squared, and the 2ab, if you write it in their factored form, you can see that they all have a factor of at least a factor of 2, at least a factor of a, and at least a factor of b. So the greatest common factor is going to be 2ab. So I can write each term as the product of 2ab and what would be left over. So 2ab times -2a, 2ab times 4b, 2ab times, well, this one you would have times 1, which brings up a good point. If you undistribute the 2ab from everything, now notice what you undistribute or what you factor out is a 2ab. The most common thing I see that happens in this case is that somebody would just factor out the 2ab and put nothing here, and they would write 2ab times negative 2a minus 4b, and they'd stop. But think about it. If you distributed this back in, there'd be nothing here to get you your third term, okay? So if you undistribute the whole factor, the whole term, you have to have a 1 there as a placeholder, like they do here, okay? All right, guys, here's 2 for you to try. Go ahead and pause the video. Okay, we're back. So the first one, you can write it as 3 times 5w minus 3 times v, and then factor out, I forgot my parenthesis there, or undistribute a factor of 3, and that's our answer, okay? The next one, if you look at them, this has a factor of 7, so does this, but this doesn't, so I can't factor out a 7. This has a u squared, a u, and a u, so I can factor out a u. This has a t squared, and just a t, so the most I can factor out is a t. So I'm going to write it as ut, the GCF of this one is ut. So this would be 7ut times ut plus 21t times ut minus 1 times ut, and then you undistribute or factor out the ut. Ut times 7ut plus 21t minus 1. Okay, don't forget to put your parentheses in there to show the factored form. All right, using the distributive property to factor polynomials with 4 or more terms is called factor by grouping, because terms are put into groups and then factored. The distributive property is then applied to a common binomial factor. What does all that mean? So this is kind of gets a little complicated. I mean, you could pause the video and read through it if you want. But basically the idea is there are 4 or more terms, and not all of the terms might have common factors, but you can group sets of 2 of them together that have common factors. Okay, so for example here, 4qr plus 8r plus 3q plus 6. Some of them have a q, some of them have an r, but not all of them. Some of them have a factor of 4, but not all of them. Some of them have a factor of 3, but not all of them. So this should scream to you factor by grouping. So what we do is you group 2 of the terms together that have some common factors and 2 other terms that have common factors. So this was already kind of set up that the first 2 had common factors and the second 2 did. So the first 2 factors have a common factor of 4 and r. So I can undistribute that from both of them. And the second group has a factor of 3 common to both of them. So I can undistribute that. Now notice that what's left over in both cases in the parentheses is the same thing. So that becomes the GCF of both of these. So if I factor that out, it would be q plus 2 times 4r plus 3. Okay? So q plus 2 becomes the GCF of this one and this one. All right? So you can factor that out, and what's left is 4r plus 3 times q plus 2. All right, here's 2 for you to try. Go ahead and pause the video. All right, we're back. So notice the first one, if you tried to group it, these 2 and these 2, it's not going to work because they don't have any common factors. You can rearrange this as Rn minus R plus 5n minus 5. Now I can group these 2 and these 2. The first set I can factor out an R, and remember this is going to be R minus n, not just R. Or excuse me, it's going to be R times n minus 1, not just n. Even though I factored out the R, you still need a 1 kind of as a placeholder. Plus, here you factor out a 5, and again, you'd have n minus 1, not just 5n. Okay, you need the 1 there as a placeholder. Notice now that your n minus 1 is the GCF of both terms. So I could write this as r plus 5 times n minus 1. Pretty cool, huh? All right, the next one, you can do it as is, or you can rearrange it. So if you do it as is, both of these have a factor of p and 3. So if I take out a 3p, I would have n plus 5. Both of these have a factor of 4, so if I took a factor of 4 out, I'd have negative n minus 5. Okay? Which doesn't quite line up. But notice they still both have a factor of a negative in them. So what I'm going to do is factor out a negative 4. If I take out a negative 4, that would make this just n plus 5. Okay? So now you can see that both have a GCF of n plus 5. So you can write it as 3p minus 4 times n plus 5. Pretty sweet, huh? All right. It can be helpful to recognize when binomials are additive inverses of each other. For example, 6 minus a, you can rewrite as negative 1 times a minus 6. It's kind of like you factor out a negative 1 and then it flips it around. So let's check this one out. Here, the way it's grouped, you can group the first two terms together and the last two terms together. The first two I can factor out a 2m and I get k minus 6, and the last one I can factor out a 7 and I get 6 minus k. Now notice these almost line up, but the 6 and k here are in the wrong spot. Like I would have to have k minus 6 and k minus 6. Well, these are called additive inverses because they're like they're the flip-flop of each other pretty much. They're the opposites of each other. This is k minus 6, this is 6 minus k. Well, what I can do is factor out a negative 1, and if I factor out a negative 1 from this one, from the k minus 6, it's going to make it into 6 minus k. So that makes the problem 2m times k minus 6 minus 7 times k minus 6, which would give you 2m minus 7 times k minus 6. All right, here's 2 for you to try. Go ahead and pause the video. Okay, we're back. So the first one, if you factor out a c, you would have 1 minus 2d. And from the second group, you can factor out a 4, and you would have 2d minus 1. Well, notice that this factor and this factor are opposites. So that should be screaming to you that one of them you have to factor out the negative. So I would do it from this one. So you would have c times 1 minus 2d, and this would turn into negative 4 times 1 minus 2d. Remember, when you factor out the negative 1, it's going to multiply the 4 and make it negative 4. And then the GCF of both of them, don't forget your parentheses, Mr. Antonucci, is 1 minus 2d. So c minus 4 times 1 minus 2d, like that. All right? All right. Next one. These two, you could factor out a p. So you would have 3 minus 2p. And these two, you could factor out a 9. So 9 times negative 2p plus 3. Notice again, you got opposites when you factored. So here I want to factor out a negative 1. So it's going to be p times 3 minus 2p. And that would multiply the 9, making it negative 9 times 3 minus 2p. All right. And then the GCF is 3 minus 2p. So completely factored form is p minus 9 times 3 minus 2p. All right. Cool. Well, that's it for this video. Please stay tuned, and we'll go over the rest of the section. See you there.